A path-breaking design for AGI, Part 5, Cognition and Control. There cannot be intelligence without control. Control over what to do and how to do it requires special mechanisms. Control requires a measurable output, a sensor, and an actuator that responds to a controller, all within a communications network. All the mechanisms required must already be implemented at the inception of learning, and these mechanisms must work without using language and numbers in the communications. However, because the controller has to use numbers internally, emotions and their mapping to a 3D space is a necessary part of the design. Control over what to do versus how to do. The problem of deciding what to do is usually driven by external events. However, how to do, usually is decided under internal control. External events can be good, or bad, they could be powerful and overwhelming, or weak, may require an immediate response, or not. Therefore, the external events have to be assessed along the dimensions of evaluation, power, and activity, EPA, to produce a proper response. The different combinations of EPA values uniquely affect our emotions. The planned response to events is depicted in a storyboard. The storyboard portrays the progressively changing emotional states and EPA values. The how may then adjust behavior to meet the depicted EPA targets. The effective EPA space. External events as independent variables typically affect us in predictable ways depending on the nature of the events, the actors, and their actions. Automatic responses could work for typical, specific instances of some events. However, atypical events may require hard-to-anticipate responses. Atypical events cause deflections in ACT because of changes in EPA mapping of emotions by the addition of new unexpected perceptions. An example, we could hear the faint, incessant wailing of an infant, over the roaring sounds of the flood, will cause serious deflections of EPA values. The E was bad to start with, P, our powerlessness, and A, the urgency of the situation, all result in a complex mix of emotions. The perception of the danger to the infant and our fear of failure, therefore changes our behavior. Storyboard to determine the what and the how. The plan to rescue the child is first checked on a storyboard representation. The decision to shoot a rope across the street to anchor it on an opposing wall might fail at first, and may require more skillful handling to succeed. Now PCT takes over. The perceptions that need to be controlled better, like the shooting and the target to aim for, are learned from experience. The feedback in terms of EPA values and other perceptions help maintain the awareness of the progress in the subtasks and the overall goal. This allows the possibility to redo the entire storyboard, or to change tack by using a different strategy or object for a subtask in the storyboard. The flexible association of solution elements like objects and strategies with problem descriptions allows such improvisation flexibly and simplistically. Subjective communications and objective actions. ACT is outward-looking and works subjectively. PCT is inward-looking, and acts objectively on algorithms and objects that it deploys to the storyboard. This requires a proper mechanism for communications between the two. The communications necessary to arrive at a workable storyboard must include emotions, sensory data, and higher perceptions. These elements are the components of the keyframes that go on the storyboard. Furthermore, the guarantee of success cannot always be assumed, and a mechanism to permit graceful failure with or without compromise is essential. The acceptability of compromises are emotion-based. The deflection caused by compromise might empower the ACT system to task the PCT system to actively explore better alternatives, through learning, if needed. The subjective-objective choreography. ACT evaluates an event and communicates problems to PCT using emotions to describe the nature of the problem. PCT then looks for a matching solution. PCT uses a solution cluster, assesses the counterfactual gaps to bridge, then decides on the manner, power, and urgency of response for each perception. PCT then submits the storyboard it has built with an emotion indicating the level of satisfaction and confidence with which it can be implemented. However, this proposal may have shortcomings that could cause deflections in ACT, making the subjective part respond with an emotion of its own. In other words, ACT deals subjectively about the problems of the external. PCT, on the other hand, deals with the solutions, internally and objectively. However, they communicate using emotions in an unambiguous manner. Summary of the design for AGI. A carefully designed set of objects and algorithms to provide support to the intelligent learning machine, similar to our autonomic nervous system, ANS. Provide training to use the ANS to acquire conscious experiences, to build subjective representations, and to construct keyframes and storyboards. Recognize reusable keyframes as perceptions and the role these play in understanding objects as a means to influence our perceptual states. Counterfactual gaps in perceptions affect emotions in a manner dependent on the subjective nature of the problem they represent in our experience. The system can learn by acquiring pre-designed objects and algorithms, and training through experience to use these to deal with new perceptions and solution clusters. The book, Purpose, covers all these in greater depth. Thank you for your interest.